which is mostly about natural and technological hazards or, or disasters. You remember I told you in the last class that we have two types
Okay.
of disasters. Yes, I can hear you.
This is the type of emergency, like what we discussed before. The two
Yes,
types.
yes, yes, and that's what we're going to discuss in detail today. Okay, we have two types of disasters. Okay, it could be natural. Okay, or technological, and you could also say man-made. Okay, you can say man-made or human-made, man-made disasters, and you're going to see examples of this. What we mean by this. Okay, so in this course, in this lesson, you should be able to describe the focus of emergency managers, various natural disasters, also technological disasters, their causes and effects, how hazard risk are assessed, and systems of measurement. You should be able to describe all these things. Now, so firstly, what do emergency managers do? Okay, so you find information at this link. Here you can see what's the job of emergency managers. So basically, emergency managers are meant to coordinate the emergency management process or the emergency management process can be what you see in the life cycle of emergency management, starting from the mitigation, okay, trying to mitigate the emergency, right from the design of the community to ensure we have community resilience. You could also have responding, okay, or preparation. You can have preparation, preparing for disasters through training, getting the necessary equipment, okay, putting in place plans, okay, and then responding to disasters when they occur, response, okay, to disasters when they occur, and then recovery from disasters. Okay, it's like a life cycle of emergency management. So going through these phases round is the task of emergency management. They do a lot of things in each of these phases. There's so much work that can be done in each of these phases, and that is the job of emergency managers. So as you already know what the definition of a hazard is, except that we repeat it here again, that is a source of danger, is anything that has potential to cause harm, that may lead to an emergency or a disaster. This is what you call a hazard, right? And when you have response requirements of an emergency event, when it exceeds capability of those established emergency services in one or more critical areas. For example, when you have an emergency happening or a disaster, and it exceeds the capability of those that are supposed to handle it, like the civil defense, they're not able to provide things like shelter, or they're not able to suppress fire, to control the fire, or they cannot control the crowd or take care for masses, for mass crowds. We classify this kind of emergency, this kind of event as a disaster. So basically, we're coming from emergency down to a disaster. All right. So, and we're going to come later on to a more bigger one, which we call a catastrophe, okay, which is greater than a disaster. Now, hazard identification is the foundation of all management activities. As I told you guys before, hazard identification, risk management, and risk assessment. This is the foundation of all safety management, emergency management activities. All right. Now, it is the realization of risk such that as what occurs when earthquake, tornado, flood, and other hazard events that emergency response and recovery capabilities and resources are called upon. All right. So now this is exactly what I was trying to explain to you. You have what you call an emergency. Now, some of the characteristics of emergency is that it is routine, all right, or routine, it is predictable, it is handled locally. These are some of the qualities of emergencies. It's something that occurs recurrently. It happens maybe, weekly. It's something that you are familiar with. It's more frequent. It's something that you can predict. It's predictable. It's more easily predictable. Okay. You could say, for example, floods, for example, floods, routine floods. Usually when it's time for rain, the rainy season here in Saudi Arabia, you know that usually you're going to have some floods in some areas. So you can predict this. Okay, and you know that this can also be handled locally. Okay, because usually there's up to a level that can be handled locally. However, when this goes outside what can be handled locally, like what you saw in the videos in the flood in 2009 flood in Jeddah, okay, 2009 Jeddah flood that you saw in the video, okay, in this case, it causes community disruption. The local capacity is overwhelmed. This cannot be handled locally. And then outside help is needed. You need help from people from outside, or maybe from Riyadh, from Jubail, from other places. You cannot handle it just in your own area, in your own local province. In this kind of case, you call it what? You call it a disaster. As for the bigger one, which is called the catastrophe, it has a regional impact. For example, it's not affecting just one country. It's affecting other neighboring countries. Infrastructure is compromised, which means that bridges, roads, they become destroyed in an earthquake or in a flood, in a tornado, and things like that. Aid is slow to arrive. There's help is not coming quickly. In this kind of case, you're going to call this what? A catastrophe. All right. So like I showed you before in the first slide, this is the life cycle of emergency management. Okay. And firstly, you have mitigation, which comes even before the emergency occurs. You have preparedness, where you prepare for the emergency, depending on what emergencies you're preparing for. You have response, which is the actual phase of response to emergency, where people go to the site, right? Where civil defense operatives or people that are responsible to respond to emergencies, when they actually go to sites to respond to these emergencies, we call this response. And then recovery is the post-disaster event, okay? After the disaster, we have recovery. Now, recovery is where you're supposed to, go back to normal, or you try to get back to normalcy, okay, by trying to get people resettled back to their houses, by trying to get businesses moving and things like that. We call this recovery. So basically, emergency managers are involved in all these four phases of the emergency life cycle. Let's start with the first types of hazards that we have, which is natural hazards. Now, natural hazards are those that exist in the natural environment as a result of what? Various processes that occur in the natural environment. This could be hydrological processes, meteorological processes, hydrological having to do with water, meteorological processes have to do with meteors or things like that. Seismic having to do with earthquakes, geologic, underground events, volcanic eruptions, mass movements, or other natural processes. And this pose a threat to human populations and communities. So all these are referred to as natural hazards. So natural hazards are often intensified in scope and scale by human activities. Now, even though they occur naturally, some of our activities, okay, can intensify the scope and the scale of natural hazards, can make them go out of proportion. This could include development and modification of the landscape and the atmosphere, just like what you know today about global warming, right? And the rising of the rising of the ocean, and also sea level, rising of sea levels. Also, you have depletion of the ozone layer, and all this type of things people talk about today regarding climate change. All right, so this can intensify the natural hazards. Also, we have modification of the landscape, like islands, building islands and things like that. All this will also intensify some of these natural hazards. Though true better understanding of natural hazards and the processes by which they affect the human and the built environment, what we can do is that we can better plan for these stressors and reduce vulnerability. So once we study these natural hazards and we understand them better, this will help us to reduce, right, our vulnerability to these hazards, okay? And then we can build our resilience. So the first one we're going to start with is floods. We're starting with floods because floods is one of the most common hazards here in Saudi Arabia, all right, and in many countries. Now, what is a flood? So a flood here is defined as an overabundance of water that engulfs dry land and property that is normally dry. So when you have a place that is usually dry and then becomes engulfed with water, we refer to this as a flood. Okay? They usually occur in large-scale weather systems, generating prolonged rainfall or onshore winds. But they may also result from locally intense thunderstorms, snow melt, ice jams, dam failures. So here it talks about some of the sources of floods. Now, floods are capable of undermining buildings and bridges. You might have seen in some countries, they can potentially sweep away buildings or remove buildings right from their foundations. Buildings and bridges, they can erode shorelines. Okay, probably we're going to see some examples. Riverbanks, they can tear out trees, washing out access roads, causing loss of life and injury. So many things, like what you saw in the video and the pictures I showed in the last class from the 2009 Jeddah floods. All right, it can cause 1 ton damage. All right. Now, flash floods. Now, here we also have a concept called flash floods. As for flash floods, it refers to when you have a lot of water coming down in a very short period of time. So these are intense storms, dropping large amounts of rain within a very brief period. I'm sure sometimes you might have seen that you have rain falling for just about for very few minutes, sometimes 2 or 3 minutes. You think it's just a light shower, but when you come out of your house, you see that the whole place is flooded. We call this flash floods. All right, the period of rainfall or the period of the storm is just very brief, but the amount of water that comes down is very huge. So this occurs with little or no warning. It just happens suddenly and the whole thing just comes down. And it could reach the fuel peak in only a few minutes. Now, floods are typically measured according to the elevation above seawater level. So this is how you measure floods. The level of the water compared to the level of the seawater, elevation of the standard water levels, okay? Now, the flood depth occurred as a flood depth expected to occur once across a 100-year period is described as a 100-year flood event. So this is how they describe floods. It means the return period is 100 years. It will occur only once in 100 years. Okay, it means a flood of this amount, of this height, this particular depth, will happen just once in 100 years, and it's called a 100-year flood. Now, typically, structures are contained within areas that are likely to experience flooding in a 100-year event are considered to be within the floodplain. So if there are any structures that are in this area, then you call those structures are within the floodplain. Floodplain are usually places that where you have a lot of water collecting. You have a lot of water collecting in these places. Sometimes you could also use this floodplain to control the flood. You could leave those floodplains out and leave them just to collect water. What I mean by that is that you could have a place that is designated as a floodplain. Okay, so you don't develop things in that area. You don't build things in that area. You only leave that area just to collect this type of excessive floods. Now, governments in many countries maintain river and stream gauges to monitor floodwater elevations for use in. Now, usually the municipality authorities will have gauges, which is like measurements, to monitor the floodwater elevations. They use this for sandbagging and dike construction, which is structures that they place at the edges of the at the edges of rivers and streams to prevent the water from overflowing to the land. Also, they use this for early warning and evacuation. Once they see that the water levels are rising above the allowable limits, they could use this for early warning and to evacuate people from those areas. So you can see an example here, which is an example of a flash flood here in the kingdom. In case see someone driving his car through the flood while people are watching. So basically, this happens in different places, you know. Now let's talk about the next one called an earthquake. Okay, earthquake is not common in many countries. In some countries, it's a very serious problem, especially in East Asia and the west coast of the United States. You know, in South America, you know, and places like that. You know, Japan, Indonesia, Croatia. We had earthquakes recently in Croatia. In Saudi Arabia, maybe probably towards Jizan. Okay, Jizan towards Yemen. You're gonna have earthquakes in these areas of Saudi Arabia. So what's an earthquake? Earthquake is a sudden rapid shaking of the earth's crust. This is caused by breaking and shifting of rock beneath the earth's surfaces. So the main effects of earthquake is that this ground shaking can lead to collapse of buildings and bridges, disruptions in gas. The gas lines could get broken, and then this could further lead to fires. Okay, that's why we call them post-earthquake fires. Okay, phone services could get disrupted. It could also lead to secondary effects Okay, this is another thing about earthquake. It could lead to other things like landslides, avalanche, which is ice, snow falling, flash floods, fires, and huge destructive ocean waves, tsunamis. When you have earthquakes occurring at the seabed, right, in the bottom of the ocean, this could lead to what you call tsunamis, another kind of natural disaster. Currently in the world, over 1 billion people live in seismic zones. Seismic zones means areas that are prone to earthquakes. That means 1 in every 7 people or 1 in every 8 people in the world are living in a place where there is a potential earthquake could happen. Now, earthquake can cause secondary fire hazard when gas lines are severed and flammable material storage sites are compromised. And that's why it's very, very important, especially in hydrocarbon facilities or in chemical plants where they have flammable materials or explosive materials. It's very important to assess the seismic performance of those facilities, okay? To make sure, because if there's an earthquake in those facilities, this could lead to explosions due to disruptions of the gas lines and release of flammable materials into the atmosphere. Now, these fires can spread rapidly among damaged buildings because water systems may be damaged and fire services are either unable to assess the fire or overwhelmed by other response requirements. Now, this is one of the challenges that you face when you have earthquakes. It will be difficult for fire service people to assess those areas where there's an earthquake, to go there and fight the services because they cannot get access to the place or because they have other things that they are trying to respond to. And because of that, these fires could spread across to other buildings and other facilities. Now, this is a picture of the Kobe earthquake in Japan in 1995. You could see it was a very serious earthquake in Japan. I can see this is a huge bridge, and the whole thing was almost, the whole thing was destroyed, you know, the whole thing was destroyed. Now, the strength of earthquakes, how do you measure earthquakes? Usually we measure earthquakes based on the Richter scale or modified Mercalli intensity scales. Usually in the news, this is what you're going to hear. You're going to say an earthquake of these 6 point days on the Richter scale. Because an earthquake of 6.5 magnitude. Okay, an earthquake of 8 magnitude, 9. This is probably in some places like Japan. Okay, now the Richter scale assigns a single number to quantify the strength and effect of an earthquake across the entire area. It gives just one number. As for the MMI, it measures the effect of the earthquake, but rather than applying a single value, unlike the Richter scale, to the event, it allows for site-specific evaluation. It will give descriptions. This is according to the effect observed at the location. So MMI, that modified Mercalli intensity scale, will probably describe the earthquake, okay? Tell you the effects of the earthquake, damage to buildings, damage to amount of shaking that was witnessed, that was seen, descriptive information to categorize the earthquake. That's what the MMI does. Though there are some tables that can be used to convert the Richter scale to MMI and convert the MMI scale to also Richter scale. So let's think about this. Now, is it possible to assign MMI values to historical earthquakes? Historical earthquakes means probably at a time where there were no measuring instruments. Okay, why there were no seismic measuring instruments to measure the magnitude of ground shaking. So it is possible to use MMI to describe those earthquakes that happened historically, But what about the Richter magnitudes? This cannot be assigned retroactively. They cannot be retroactively assigned. That means that you cannot assign the Richter magnitudes to earthquakes that happened a long time ago. Why? Because there was no way to measure the magnitude of those earthquakes. So this is one of the reasons. The reasons, because here it says, why do you think this is true? The reason is because in historical earthquakes, there were no instruments to measure them at that time, right? Earthquakes that probably happened 300 years ago or 200 years ago, when there were no measuring instruments or seismic instruments to measure those earthquakes. So when you want to say which one of these tools might be useful in terms of disaster planning and why? Well, both of them may be useful in the sense that for the earthquakes with numbers, they could be used by scientists. That's Richter magnitude scale. They can be used by scientists and engineers that need to know the exact value. They need to assign a numerical value to the earthquake. And this helps in disaster planning, in design of buildings and structures and facilities. As for other planners like managers, they might need, rather than just the numerical value, they might need descriptions, right? You know the magnitude of the earthquake in terms of the Richter scale, but we also need to know what is the effect of the earthquake on the surrounding environment and people and buildings. What is the real observable, perceivable effects? So in this case, the MMI scale might be more useful in terms of disaster planning. So like I said here, in this table, you could see that the MMI intensity scale is on this column, and the Richter equivalence is on this column. So if we look for an earthquake that is, let's say, 6.2 to 6.5, okay, if there's an earthquake happening in the country, that occurs in the country, or that occurs in the country, and 6.2 to 6.5 on the Richter scale, it could be described as 8 on the MMI scale, which is destructive, described as a destructive earthquake. And the description to that will be damage slight in specially designed structures. Special designed structures means that they are considered to be earthquake resistant. Now, considerable damage in ordinary substantial buildings with partial collapse, damage greatly in poorly built structures, fall of chimneys, factory stacks, columns, monument walls, heavy furniture overturned, and this and that. So these are examples of the effects that may be perceived from such an earthquake. All right, and then if you go to an earthquake that is greater than 8.1, okay, 8.1 and above, this can be described as 12 on the MMI scale, which is catastrophic. And that is damage is nearly total, almost complete ruin and damage. Large rock masses displaced, lines of sight and level are distorted, objects are thrown into the air. All right, so this is how you can also understand the MMI scale and the Richter scale. And once you get information on the Richter scale, you can compare to the MMI scale, all right, and see also what are the description of or sensations experienced or damages experienced during that earthquake. Now let's look at hurricanes. Now, as for hurricanes, they're described as cyclonic storms. Okay, cyclonic means moves in a circular pattern. Okay, cyclonic storms that begin as tropical waves and grow in intensity and speed. This has sustained wind speed of greater than 74 miles per hour. Okay, so when you have this kind of cyclonic storms, greater than 74 miles per hour with wind speed greater than 74 miles per hour, these are described as hurricanes. Now, hurricane winds extend outward in a spiral pattern, as I've shown you here, okay, as much as 400 miles around a relatively calm center of up to 10 miles. So the diameter, the exterior diameter might be also 400 miles, okay, while the center can be about 30 miles. All right, and this center is called the eye, okay, it's called the eye of the earthquake, okay, it's like a cone, okay, probably like a cone this way, and here can be 30, while this can be 400, okay. Now, once overland, hurricanes cause further destruction by means of torrential rains and high winds. Okay, so hurricanes are usually described in the Saffir-Simpson scale. Just like we have the MMI, and the Richter scale for earthquakes, we have what? The Saffir-Simpson scale for to describe earthquakes as well. Now, the costless disaster in US history in pure dollar figures, about 80 billion US dollars. And one of the dead years in terms of life lost and injuries, almost about 1,836 people were killed, is Hurricane Katrina. Most of you must have heard about Hurricane Katrina, one of the most famous earthquakes occurring in history and in the history of the United States. Okay, so it had about 18 billion US dollars losses and 1,836 people who were killed. Now, this was the Saffir-Simpson scale looks like. So we have category 1 to category 5. Okay, on the Saffir-Simpson scale, I can see the wind speed that you get. Okay, wind speed over 155 miles per hour is category 5. And here you can see some of the potential effects and damage. complete roof failure on many homes and industrial buildings, building failures, damage to lower floors of structures, massive evacuation on low ground and things like that. Now, this was a picture of a neighborhood during Hurricane Katrina. You can see that not just it comes with a storm, that is water and wind at the same time. So it brings all this water to floods the entire place, while the wind damages the property, the structures, roofs, buildings, and all that. As for tornadoes, there's a rapidly rotating vortex or funnel of air extending groundward from a cumulonimbus cloud. Okay, so it's a type of cloud, and then this creates this tornado, which comes this way, like this. You have this coming this way, but it comes like this in a funnel. Okay, this way, and extending groundward from cumulonimbus cloud, exhibiting wind speed of up to 300 miles per hour. So most tornadoes remain aloft. Aloft means that above ground, but few do touch the ground. When they come to the ground, they have devastating effects on everything in their path. They destroy everything in their path. Okay, usually they will pass through the path of least resistance. They will not pass through the mountains. They will pass through valleys and things like that. So the forces of tornado wind speeds are capable of lifting and moving huge objects. They could carry huge objects into their vortex and keep rotating them and finally dump them somewhere else, destroying or moving whole buildings and siphoning large volumes from bodies of water and ultimately depositing them elsewhere. So tornadoes typically follow the path of least resistance, okay, not where you have rocks and things like that. So they'll follow valleys, right, that have the greatest exposure. Buildings and people living in valleys will have the greatest exposure to damage. So in measuring tornadoes, we have what you call the Fujita-Pearson tornado scale. Was created since 1971, and this one is used to measure the tornadoes. This is an example of a technology to be used during tornadoes. It's called a safe room. It was developed by FEMA, which is Federal Emergency Management Authority of the United States, and Texas A&M University. So it's called a safe room. I can see the construction through this section. You can see the construction of the safe room. Okay. Next, we have what we call wildfires. Now, wildfires or wildland fires can be categorized into three types. We have surface fires, we have ground fires, and we have crown fires. Now, what are surface fires? Now, when you go into the forest, if any of you has been to the forest, if you go to the forest and you step on the ground in the forest, you see that there's some space between the shrubs or the leaves and broken branches of trees on the ground and the floor of the forest floor itself. So this part where you have the surface where you have this leaves and all that is called the surface of the forest. When you have the fire burning on this surface, we call it a surface fire. It's the most common type and it burns along the floor of the forest, moving slowly and killing or damaging trees. As for ground fires, this happens on the ground itself, usually started by lightning and burn on or just below the forest floor. That is below the, the surface fire. All right. Well, ground fires burn at the trees, the canopy, the forest canopy, which is the top of the trees of the forest, high above the ground. And therefore, they spread much more rapidly due to wind and direct contact with nearby trees. Now, the problem with forest fires is that apart from climate concerns and damage to the environment, like what you saw happening in Brazil, in the Amazon in Brazil, what happened also in Australia, apart from these things, also they affect people when we have what you call the wildland urban interface, because urban settlements are beginning to encroach on these wildlands. Okay, people keep developing buildings and communities, and they keep moving closer and closer to these wildlands. So this also poses a huge threat to the urban areas that are close to the wildlands. And this brings threats to the human population, increases. The threat to human population increases drastically. So this is an example of a forest wildfire somewhere in Russia. You can see the fire burning through the forest and burns all the trees. So I think we're going to stop there for the class today. Next class, we're going to continue from mass movements. So thank you for listening, and let me see if you guys have any questions.